This is a short Imperva video on SIEM integrations focusing on the Imperva API and Splunk. Let's begin with a brief overview of SIEM and how it appears in the Imperva dashboard. SIEM plays a crucial role in modern cybersecurity by providing organizations with the tools to centralize and analyze security events across accounts and websites. Imperva provides near real-time latency of logs, so you can more effectively monitor and respond to cyber threats. Our flexible connector types let you quickly integrate with various SIEM solutions, making it easier for your organization to enhance its security posture. Imperva offers pre-built SIEM packages that provide dashboards, queries, and analytic tools. This video focuses on the Splunk SIEM package and how to integrate it with your Imperva logs using the Imperva API. By the end of this video, we will have an Imperva dashboard that displays a map showing source of attacks and the number of attacking countries, attacks, attack types, attackers, and much more. Our dashboard's many metrics will help you identify spikes in security events across all traffic so you can respond proactively to potential threats. You can also monitor the countries from which traffic originates, which is vital to detecting abnormal activity, especially from suspicious countries. Now let's run through the steps for a common Imperva SIEM integration using the Imperva API and Splunk. We'll begin by configuring Imperva to send our SIEM logs to the Imperva API. From the Imperva console, go to Account Management, expand the SIEM Logs section, and select WAF Log Setup. Activate the sending of logs. Our connection setting will be Imperva API. Copy-paste the API ID, API key, and log server URI. The application key will only be generated once, but you can regenerate it if needed. Since we want to integrate the Splunk application, we'll download the Splunk SIEM package called Encapsula.spl. Now let's install the Imperva application for Splunk that we just downloaded. Go to your Splunk console and log in. From the Apps menu, select Manage Apps. We need to install the application that we downloaded from the Imperva console. Click Install App from File. Click Choose to find the file we previously downloaded called Encapsula.spl. Once selected, click Upload. Now, under Apps, we can select the new Encapsula application. Right now, the Imperva application in Splunk is still empty. Soon we will download the logs from the Imperva API and send them to Splunk. First, we need to configure our Splunk application to receive logs. Go to Settings, Data Inputs. On the Splunk console, find the local input HTTP event collector and then add it. Now, click the New Token button. Type in a name for the endpoint, Imperva Logs, and click Next. Under Input Settings, click Select Source Type, and enter Encapsula. Click Review to display all the settings. After you check that all the settings are okay, click Submit. Now copy the token value and save it. We will need it soon to use in the download script. Now let's download the logs from Imperva API and ship it over to the HTTP event collector we just created. Go to the Imperva Git repository and clone Encapsula logs downloader. Now, we need to edit the configuration file of the logs downloader script. Take the three parameters that we had copied when creating the connector: API ID, API key, and base URL, which was called log server URI. Now enter them in the matching fields in the configuration script. Paste the following values that we created using the Splunk HTTP event collector: Imperva Splunk HECIP, Imperva Splunk HEC port, Imperva Splunk HEC token. Now run the script and show a valid output. Now let's see our logs in the Splunk application. In the Splunk console, under Apps, we can select the new Encapsula application. We are now looking at the main view attack logs, showing data from the last 7 days. The dashboard clearly displays all the attacks with a map that shows their sources: number of attacking countries, attacks, attack types, and attackers. From the Overview dashboard, we can view the type of attacks, where the attacks originated, and the events over time. For example, here we had a low number of security events, then a spike which may indicate that there had been an attack. From traffic logs, we can view the metrics for application performance: traffic by top IPs, and requests answered from cache, as well as how many were closed due to a bad connection.